everyone, thank you so much for joining me for this lesson. Today we're going to be looking at harder questions for the topic of batteries. So this is a simplified cell representation of a lithium-ion cell. The reagents in the cell are absorbed onto powdered graphite that acts as a support media which allows ions to react without a solvent, for example water. The half equation for the reaction at the positive electrode can be represented as follows. So for A, identify the element that undergoes a change in oxidation state at the positive electrode and write the oxidation states. So first I'm going to write the equation. So for A, we have Li plus COO2 plus an electron goes to form Li plus and COO2 minus. And so now we can work out all the oxidation states. So we have Li plus, which is plus 1, and then for COO2 we have minus 2, and that has to equal 0. So X equals plus 2. So we have CO as plus 2 and oxygen as minus 2. And then here we have Li is still plus 1, and then now we have COO2 minus, so that's minus 2, minus 4. So X equals plus 3. And if you can't remember how to work out the oxidation states, then quickly go back to the redox videos. So we have CO is now plus 3 and oxygen is still minus 2. And so which one has been oxidized? Well, we can see that this cobalt has been oxidized because its oxidation number has gone from plus 2 to plus 3, because oxidation can be defined as when the oxidation number increases. And so identify the element that undergoes a change in oxidation state is cobalt, and the oxidation states are plus 2 and plus 3. And then for B, write a half equation for the reaction at the negative electrode during operation of the lithium-ion cell. And so this is happening at the positive electrode. So at the negative electrode, we have this. And so because it's the negative electrode, that's reducing this. So this is what's happening at the positive electrode. So what's happening at the negative electrode must be the opposite. So electrons are given out. So we have lithium, and that goes to form lithium plus and an electron, because this electron is then going to this lithium plus and COO2 to form this ion. And then for C, suggest 2 properties of platinum that make it stable for use as an external electrical contact in a cell. It's quite useful to just remember a few properties about platinum because these kinds of questions come up quite a lot. So number 1 is that it's inert, so it doesn't react with any of the other things in the solution. And also it can conduct electricity, which is very important because we're trying to connect it up to wires and measure the EMF. And then for D, suggest one reason why water is not used as a solvent in this cell. Water actually reacts with lithium and it forms lithium hydroxide, and that's the reason why. Lithium hydroxide. Before I move on to question 2, feel free to click off the video and try it for yourself first. So this question is about the alkaline hydrogen oxygen fuel cells. And so for A, use the table to calculate the EMF of the alkaline hydrogen oxygen fuel cell. So what we do is we use the equation EMF equals standard electrode potential of the right minus the standard electrode potential of the left. And so the 2 equations that we need are this one and also this one, because these are both working in alkaline conditions. And what we do now is we think which one is being reduced and which one is being oxidized. Well, one thing to note is that this table is actually not the electrochemical series because they've written it the other way around. And so it's very important to spot that the most negative is actually on the bottom because that can trip you up. So this means that this is going to reduce this. And so the bottom equation is the one which is giving away the electron. And so that means that the bottom equation is the cell that we put on the left, and the right equation will be the one on the top. And so this gives us an EMF of 0.4 minus 0.83. And that equals plus 1.23 volts. So for B, write a cell representation. So we've already kind of thought this through. We know which ones are on the right and which ones on the left, but now we need to figure out which of the species in those half cells will be going in the middle and the outsides. So the rule is that the most oxidized ones are in the middle, so the ones which have bigger oxidation numbers. And so let's first work on the left half cell. So this is where this equation comes in. So we have to have this hydroxide and this hydrogen. Some people like to include the water as well, but it's okay to miss it out as well. So now we think which one has the higher oxidation number. So OH minus and H2, and it's for hydrogen. So the oxidation number for H2 for hydrogen is 0 because it's an element. And then for this one, it would be plus 1 because the oxygen would be minus 2. And then the hydrogen will be plus 1, and that equals the overall charge, which is minus 1. So hydrogen is plus 1, and that means that the OH minus goes in the middle. And because the OH minus and the H2 are not solids, that means we need to use a solid, so we use platinum. So platinum always goes on the outside as convention. And then we use a solid line because we're changing phases now. And then we have the H2, which is a gas, and then another solid line, the OH minus, which is aqueous. And now we have the salt bridge, which is the two double lines. And now we work on the other equation. So now we need to have the oxygen and the OH minus. And so again, we work out the oxidation states. So we have O2 and OH minus for oxygen. So for oxygen, the oxidation state in O2 is 0 because it's an element, and in here it's minus 2. And so that means that the oxygen goes in the middle because it's got a higher oxidation state. So we have oxygen, the gas, separated by a straight line, and then the OH minus ion, which is aqueous. And then again, we need something solid, so we use platinum. So platinum goes on the outside. And this is the cell representation. Then for C, construct an overall equation that occurs when it operates. So when it operates, that means that the electrons are going like normal, so from the more negative electrode to the more positive electrode. And so that means that the electrons are coming from this bottom equation. So that means that this bottom equation needs to be reversed before we combine half equations. One thing to spot is that the electrons are different. So we've got 2 electrons here, but 4 here, which means that we need to multiply this equation by 2 so that we can cancel out the electrons at the end. And so we have 4OH minus plus 2H2 plus O2 plus 2H2O plus 4 electrons, and this goes to form 4 waters plus 4 electrons plus 4 hydroxide ions. And now we can cancel stuff out. So we can cancel this hydroxide ion out, and we can cancel these electrons out, and we can also cancel these 2 waters out and turn this into a 2. And so the overall equation that we have is 2 hydrogens plus an oxygen goes to form two waters. And then for D, give one reason other than cost why the platinum electrodes are made by coating a porous ceramic material with platinum rather than by using platinum rods. And that's because the surface area is increased greatly, so it happens a lot quicker. So increase the surface area, so we have faster reactions. And then for E, other than its lack of pollution, state briefly the main advantage of a fuel cell over a rechargeable cell when used in an electric motor that propels a vehicle. The main advantage is that we don't have to stop it to be recharged because it has that continuous flow of hydrogen and oxygen. So we have a continuous flow of hydrogen and oxygen. So as long as there's a continuous flow of hydrogen and oxygen, that means that the electric motor will be able to propel the vehicle. And then for F, hydrogen-oxygen fuel cells are sometimes regarded as a carbon-neutral energy source. Give one reason why this may not be true. And the reason why is that if we are to have a continuous flow of hydrogen and oxygen, where they come from is from the burning of fossil fuels. So this is not good for the environment and it's not carbon neutral. So the answer is burning of fossil fuels to produce hydrogen and oxygen is not carbon neutral.